Hi, very good morning. Today, in our lecture series, that is wide band gap devices lecture series, we are going to discuss the topic under the unit of switching characterization of WBG, that is wide band gap devices. So, the topic name is design thinking based double pulse test setup. Come, let's get into the topic. So, what is double pulse test setup? Actually, it is use of this test is minimizing switching losses continues to be a major challenges for power device engineers working on SiC and GaN devices, that is silicon carbide and gallium nitride devices. The standard test for measuring switching parameters and evaluating the dynamic behavior of SiC, and gallium nitride MOSFET and IGBT is the double pulse test, that is a DPT. Double pulse test can be used to measure energy loss during device turn on and turn off, as well as the reverse recovery parameter. So it performs a double pulse test is performed using two devices. One device is the under test, that is DUT, and the second device is typically the same type of device as the DUT. Note that inductive load on the high side device, the inductor is used to replicate a circuit condition that you may have in a converter design. The instruments used are power supply or SMU to supply the voltage, an arbitrary function generator, that is AFG, to output pulse that triggers the gate of the MOSFET to turn it on and start conduction of the current, and an oscillator to measure the resulting waveforms. So this circuit diagram is nothing but of a double pulse test setup circuit diagram. Here, as we mentioned in the previous slide, here we have device under test. There is a DUT is there, and the inductive load is there. That is the AFG, arbitrary function generator, to trigger the output pulses is there, and voltage is there. So this setup is used to perform the double pulse uh, experiments, right? And here this is the prototype model. That's a product model of double pulse test setup. As we know, this is the function generator where it triggers the it generates the output pulse to perform the double pulse test setup, and the corresponding output waveforms we can view in the oscilloscope that we use to see the signals. And how to generate the gate driver signals for double pulse test in this model. So here the double pulse test setup model we have seen is, that is Tektronix AFG 31000. This model we have seen for an example. So here how to generate the gate driver signal means, the easiest way to generate the gate drive signals to perform a double pulse set is used to an arbitrary waveform generator AFG. An AFG may be used to generate the gate drive signal to perform a double pulse test. The Tektronix AFG 31000 has a built-in double pulse test application to create the pulses with varying pulse width. So how to measure turn on and turn off time and energy losses? An oscilloscope is a great tool for capturing the double pulse waveforms. So you may obtain the turn on and turn off time parameters of your device with the Tektronix 456 series BMSO and the wideband gap double pulse test application software, that is WBG DPT. Everything you need to capture a parameter that is at your fingerprints. The WBG DPT option offers automated switching, timing, and diode reverse recovery measurements per JEDEC and IEC standard. So the double pulse test circuit, the output waveform, as we already know, it can be measured by the oscilloscope. So the sample oscilloscope output is shown on the slide. Here we can see the VDS, IDS, then VGS. Every the changes is can be witnessed in this oscilloscope, and the various parameter details, that is values we can view in this window. So the ultimately the oscilloscope required to view the waveforms. As we do the several experiments for double pulse test setup, also we supposed to need the oscilloscope. And here double pulse, I mean measuring of turn on and turn off turn on timing and energy losses that we already, as we said, here also we can checked with this Tektronix 456 series BMS4 that we can measure. So measure reverse recovery. That is reverse recovery time of a diode is a measure of switching speed in the diode and thus affects the switching loss in the converter design. Reverse recovery current occurs during the turn on and turn on of the second pulse. As shown in the diagram, the diode is again conducting the forward condition during the phase 2. As the low side MOSFET turns on again, the diode should immediately switch to the reverse blocking condition. However, the diode will conduct in reverse condition for a short period of time, which is known as the reverse recovery time. The reverse recovery current is translated into the energy and directly impact the efficiency of the power converter. So this is the circuit diagram where the waveforms can be generated. So thanks for watching this video. Thank you.